Hello everyone. So welcome you all to Ashok Tutorials Meghalaya's first MTED channel. So my dear friends, today in this video we are going to discuss mathematics, and the topic we are going to discuss is nature of mathematics, and under nature of mathematics specifically we are going to talk about patterns and logic. So what are patterns? See, patterns can be anything like black, white, black, white, black, white, black, white, right? Yes, no, yes, no, yes, no, yes, no, 1 2 2 1 1 2 2 1, anything. All right, so pattern. And logic means when we apply the logic in certain things. All right, so let's see what pattern is all about. Pattern refer to regular and repeated arrangements or sequence of numbers, shapes, or objects. See, this is what I just told you about the pattern. All right, so it's a pattern. They can be visual, numerical, or conceptual in nature. See, pattern can be of anything. It can be numbers, it can be visuals which you can see, it can be shapes, or it can even be the concept or the ideas. All right, so identifying patterns often involve observing similarities or repetitions and making predictions based on these observations. See, now when you are able to identify the pattern, see, now when we are preparing for MTET exam, what do? We try to understand like what is the pattern of question, what is the type of question, like how they are asking. Are like, suppose if you're smart enough you will think about like, all right, so four options are given. I can see that generally the answer, the correct answer is always there in option number B. So you will be writing 150 questions, right? So out of 150 you might find that 100 correct answer are all of option number B, 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 like that. So this is a pattern, right? This is just an example, right? Now, patterns can be simple like the sequence of natural numbers. See, 1, 2, 3, 4. These are pattern, or more complex such as fractions or fractal patterns or Fibonacci sequences. All right. Now, recognizing patterns help mathematicians and scientists make predictions and understand underlying principles in various fields. So what happens here? When we recognize the patterns, it will help us, the students, the scientists, the mathematicians, to make what? To make the predictions and to understand the different type of principles and theories involved, right? Now let us talk about briefly about the logic. What is logic? So logic in mathematics involves using rules and reasoning to make deductions, draw conclusions, and solve problems. See, many of the questions you will see that we have logical reasoning, right? Logical reasoning in net exam you will find logical reasoning is there. Then in even in seated exams, logical reasoning questions are there, but in MTET exams I hardly find any logical reasoning questions, which means when logical reasoning is there, the type of question becomes very tough. But when logical reasoning is not there, it is not much tough. So when we when logical reasoning is given, we have to think about the particular topic more and more and more. We have to put so much of pressure in our brain, right? Because we have to reason out, we have to find the reason why the options given here are all correct, or 50% correct, 50% not, or whatever, right? So it is the foundation of mathematical proof, where statements are justified based on a set of axioms and logical arguments. So logic is the foundation of mathematical proof, where statements are made or are clarified or justified based on what? Based on the set of axioms and logical reasoning or arguments. All right. Formal logic includes propositional logic and predicate logic, which provide systematic ways to evaluate the truth or falsity of statements. So, formal logic includes, what do formal logic include? It includes the propositional logic and predicate logic, which provide what? It provide this systematic way to analyze or to evaluate the truth, whether the statement is true or false, or why it is true or why it is false. All right. Informal logic, on the other hand, is used in everyday mathematics to make valid arguments, often involving if-then statements and deductive reasoning. So when we talk about informal logic, these are the logics which we use in everyday life, inside and outside the classrooms. All right. Now, logic helps mathematics validate their findings, ensure the accuracy of mathematical theorems, and construct rigorous mathematical arguments. See, when people say, sometimes when somebody says, last night I have seen a ghost, then you will say, why are you talking so illogical stuff? because there is no logic, which means there is no point when you say that you have seen a ghost, because ghost does not exist. So this is what you might say, right? So logic means something which you can believe or reasonable, but illogical means there is no logic, it is pointless, baseless, right? In essence, patterns help mathematicians recognize regularities and trends, while logic provide the tools to analyze and prove mathematical statements, making these two elements fundamental in the study application of mathematics. So, both patterns and logics go hand in hand together. So, the pattern helps the mathematicians to recognize whether something is getting repeated again and again, or it is, you know, it's in a trend, or is it in a way which can be recognized, while logic gives the reason or analysis of why something is true or false or whatever it is. All right. Universality. Mathematics is a universal language. It transcends cultural and linguistic boundaries, allowing people from different backgrounds to communicate and understand mathematical concepts. So, everywhere in the world mathematics exists, right? So mathematics is a universal language, because numbers are there everywhere, in your book, in your clock, in your money, everywhere in your family. So whenever we count something, number is involved, right? So that's why we say mathematics is universal, right? Now, logical reasoning. So mathematics is based on rigorous logical reasoning. It follows a set of axioms and rules with reference to derive new truths. Mathematical arguments are expected to be precise and free from ambiguity. So that's why we know, like when we talk about the different theories, we are able to prove those theories. Suppose Pythagoras theorem, we are able to prove that theorem. In mathematics, we don't take anything without proof. Whatever we do in maths, whatever we follow in mathematics, the formula, the theories, the principles, these are all proved. All right, these are all proved by the scientists, the mathematicians. All right, then only we follow it. There is no doubt, it is crystal clear, right? Now, pure versus applied mathematics. So what is pure mathematics and what is applied mathematics? So mathematics can be categorized into pure and applied mathematics. Pure mathematics explore abstract concepts and the relationship, often without immediate real world application. So pure mathematics means which do not involve the real world experience, and it is more or less about the abstract concepts. However, applied mathematics, on the other hand, uses mathematical tools to solve the practical problems in science, engineering, economics, and other related fields. Right? Creativity. Despite its logical foundation, mathematics also involves creativity. Mathematicians often describe the process of discovery as kin of kin to art. Finding elegant solutions to complex problems requires creative thinking. So you can also say that mathematicians are creative, because it is also a very creative subject. All right. Infinite possibilities. So mathematics deals with the infinite possibilities. There are infinitely many numbers, geometrical shapes, and mathematical structures. This infinitude is a unique feature of mathematics. See, there are two, we can categorize anything into finite and infinite. Finite means which can be counted. If I ask you to count the stars, will you be able to count? No. Why you are not able to count? Because the stars are infinite, which means it is uncountable. The hair on your head, it is uncountable, right? But when we say finite, means which can be counted. All right. Now, unchanging truth. Mathematical truth are unchanging and independent of human perceptions. A mathematical statement that is true today will be true in the distant future, and it is true in the distant past. See, mathematical truth, whatever the formula, the truth we have found in mathematics, it is not going to change today or tomorrow or any time, right? Because it is already proven in the past, it is proven in the future, it is proven in the present. So that's why we just accept it. It is universally accepted, and we progress with our mathematical stuffs, right? Now, interconnectedness. Mathematics is highly interconnected. Concepts in one branch of mathematics often have applications in relationship with concepts in other branches. This interconnectedness allows for development of new mathematical ideas. So, which means mathematics is a collaborative subject, which means it is interconnected with other domains or other subject or related areas, right? Historical evolution. Mathematics has a rich historical evolution with contributions from various cultures throughout history. It has continuously evolved and expanded over the centuries. So, mathematics is a history as well because we have seen many historical evolutions or events in the field of mathematics. All right, open ended questions. Mathematics is not a closed field, there are still many unsolved problems and conjectures. Mathematicians actively work on proving or disproving these conjectures, leading to ongoing discoveries. So, open questions. So, mathematics welcome different type of questions. You can ask the mathematicians different type of questions which are yet to be solved, mysteries which are yet to be solved and resolved. And uh, mathematics actively work on proving, all right, it work on proving something or disproving something, all right. So in essence, the nature of mathematics involves abstract thinking, logical reasoning, creativity, universality, and a quest for discovering unchanging truth. It plays a fundamental role in understanding and describing the patterns and structures that underlie the universe, making it an essential tool for science, technology, and other related fields. So, as you can see, that the nature of mathematics is very vast. It is precise, it is accurate, it is abstractive, it is hierarchical, sequential, pattern, and logical. Alright. So, this is all in this video. So, thank you everyone for watching.